All right, everybody, welcome back. Today we're going to be going through our first module in the Facts of Life course. And really, what we're going to be trying to do today, rather than thinking exactly, science as a subject, we're really going to be thinking about science as a process and how biologists use this process to evaluate literature that's already out there and design experiments. So that's what we're going to be evaluating today. So first of all, I'd like all of you, if you can, when you're watching this, to go ahead and pause right now and take some time to read through this page. So we're going to start every class with a scientific figure, or in this case, a scientific abstract. An abstract is essentially a summary of what a scientific study does. And it should give you the main results, the questions that the scientists were hoping to answer, and any conclusions that they're hoping to draw from their research. Now, this is essentially a scientific paper in a few hundred words, no less. So go ahead and pause the lecture and take some time to read through Okay, so now that we've had a chance to read through the abstract and take just a brief look at the scientific figure, you'll notice that this study is what is the most current research and the largest clinical trial we have of hydrochloroquine and its efficacy against COVID. And we're going to be using this abstract and this study to evaluate how biologists went through and evaluated whether or not hydrochloroquine is an effective treatment for and prophylaxis for COVID. So for this module, we're going to be going through 4 specific questions. So those questions are what you see at the beginning of your chapter reading. So you'll see them every time we go through them. And those are really going to essentially set the stage for how we're going to be thinking about the lecture and how we're going to be thinking about the case studies that are presented both in your book and during these lecture times. So the questions that we're going to be working through today are exactly how is a scientific method used to test hypotheses? How does the scientific method apply in clinical trials? How can you evaluate the evidence in media reports of scientific studies? We're going to be spending a large chunk of our time on this because ultimately what I'm hoping you're going to take away from this course and these series of lectures is the ability to think critically about scientific information and scientific figures and studies. And lastly, we're going to look at what factors influence the strength of scientific studies and whether the results of any given study are applicable to a particular population. So we're really going to spend some time understanding what makes a good scientific study, what makes a poor scientific study, and how scientists go about creating questions to examine. So we're going to spend some time in this first lecture series of what is a scientific method and how is that used to test hypotheses. So we're gonna zoom out a little bit far here. So really, what is science? Rather than thinking about it as a subject, we want to think of science as a process. We want it to think of it as a method to ask and answer questions and critically evaluate observations. So rather than thinking of it as a subject, we're going to be thinking specifically of science as a process, and that's going to be the subject of a worksheet that you guys are going to be working through this next week. So what we're really wanting to draw from this is that science is essentially a method. It's a way to observe observations and draw conclusions from experiments. So thinking about that, I want you to think back to the abstract that we showed on that first slide and think about what is the question that the scientists were trying to answer in that paper. So just keep that in the back of your mind as we go through these next couple slides. So really the first part of any scientific inquiry is to be able to formulate a good question. And we're going to be spending a lot of time over the semester evaluating how we think about questions. And this is going to be in the form of those discovery essays and those discovery questions that we're going to do every week. So pay attention to how we're thinking about questions in terms of science. So ultimately, when you start thinking about science as a question, it can start with something just as an interesting informal observation. So this could be something you see in the laboratory. This could be something a clinician sees in a patient, or it could be something completely anecdotal. And oftentimes this is unreliable, and most importantly, these are untested ideas. This is simply a way of thinking and driving to what we're going to actually plan to evaluate a specific question. And so once we sort of have this sort of basis that we're going to start with, this observation or something that's interesting, the first thing that we need to do is we need to evaluate what evidence currently already exists. So in reference to the hydrochloroquine study, a scientist might have said, well, I've seen that hydrochloroquine works well with other respiratory viruses. And because there's been some studies previously that have shown efficacy with hydrochloroquine, I propose that hydrochloroquine might be an effective prophylactic. Again, this is just the idea of how scientists might be thinking about creating these questions. So the next step is to really understand the relevant literature, really going through and understanding what already exists out there. However, this can be very challenging, especially when you're new to science and new to reading scientific information. There's a lot of evidence out there. So how can you start to rank what is a good study and what is a poor study? So just a very, very brief way to sort of evaluate a scientific journal or a scientist is something called the H-index. Now, there are a lot of problems with this index, so just as a caveat moving forward, but essentially it's the number of publications that a scientist puts out into the universe, and then how many times those scientific papers are then cited by other scientists. So obviously there's some problems with an index like this. People who have really high indexes are more likely to be older, well-established researchers. So a younger scientist might have a perfectly good and valid study, but might not have a very high H-index because they're just getting out there. And especially when we also think about English as a second language scientists, the vast majority of really good scientific journals are all in English. So that can be a barrier to getting information out there. So just keep that in mind. But a good way to sort of think, is this person a good scientist? Or is this person contributing to the scientific field? You can look at the H-index, and the higher that H-index is, the more likely they are to be a, quote, real scientist. Again, lots of problems with the H-index, but a good, quick way of evaluating whether or not somebody is contributing to the field. Another way that you might be able to think about scientific literature is looking at something called the impact factor of different journals. So this is basically a score of when you submit a paper to one of these journals, how many times is that paper likely to be cited by somebody else? So some journals, like the one that this study was published in, this hydrochloroquine study, was published in the New England Journal of Medicine. That has a very high impact factor of around 70. And then when you start looking at other journals like the International Journal of Public Health Research, you might see an impact factor of something like 2 or 3. So a good way to look briefly, is this study credible, is to look and see what that impact factor of the journal is. However, even when you go and find good journals, you'll still might find conflicting evidence. So this was brought up in your readings for this week, is looking at coffee and whether it is a good or bad thing for human health. And you see that there's lots of variation in these studies. So even though you might have a good idea of what a scientific journal is and that there's evidence for your hypothesis, there still may be conflicting evidence in the literature. So how do we go about evaluating conflicting evidence in the literature? That's what's going to be our next topic. So see you soon.